Welcome to the SEI Podcast Series, a production of the Carnegie Mellon University Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. A transcript of today's podcast is posted on the SEI website at sei.cmu.edu/podcasts.
Welcome to the SEI Podcast Series. My name is Suzanne Miller, and I'm a principal researcher in the SEI Software Solutions Division. Today, I'm very pleased to welcome to our podcast Garret Wassermann, a vulnerability analyst, and Jeffrey Gennari, a senior malware reverse engineer, both with the SEI CERT division. Today, they are joining us to talk about Kaiju, not the monster-heavy genre of films and television, but equally monstrous series of tools that they have developed that allows for malware analysis and reverse engineering that helps analysts take better advantage of Ghidra, the National Security Agency's reverse engineering tools. So we have monsters killing monsters, and I love that. So welcome to you both. And before we delve into that topic, could you tell us about your backgrounds and the work that you do here at the SEI? What's the best part of your job? Jeff, you've been a guest on our podcast series before. Why don't you start and tell our audience a little bit about yourself?
Sure. So I've been working in the CERT program here at the SEI for many years. I've done just about everything you can possibly do at CERT. I've been in vulnerability analysis work, secure coding, malware analysis, operational work. And so over that time, one of the things I love most about the Institute is that you get to see not only the day-to-day problems in the government and work on them, but you also get to take a step back and think about the longer-term trends, the deeper research that we get a unique opportunity to pursue here, given that we're supposed to be filling in the gaps. So I just love that. It's very dynamic, and you always get to reinvent what you're interested in.
Actually, that's one of my favorite things about this place too, because I've done several different kinds of research areas, and that is unique about the SEI indeed. Garret, what about you? Why are you here? What brought you here? What keeps you here? What is it that's exciting for you here?
Yeah, I've been a member here at CERT for 7 or 8 years now, I think. And I started as a vulnerability analyst, understanding security bugs, security vulnerabilities in common software that people use every day, or common hardware like home routers and things. And I would work with both researchers and the vendors, software and hardware vendors, to better understand those vulnerabilities and how we can protect end users, and to make sure that patches were developed to fix those things and send out to the end users so that everyone could finally be secure, right, as things are discovered. But in all of that work and trying to better understand these vulnerabilities, you see over time trends and in different ways that things can go wrong. And so naturally you want to look more into the details and better understand those problems. And that was what led me to eventually moving kind of from vulnerability coordination work, we call it, coordinating patches and fixes, into executable code analysis and malware analysis, where I work with Jeff and others to better understand where these vulnerabilities come from and to identify them in software and to create tools that can help automate a lot of this process, because a lot of it is really difficult to do and very time consuming for analysts. So if we can try to find those patterns and things that link problems together, we can more quickly find and fix these issues and make sure that people are protected.
And I appreciate that. As a recent victim of a clickbait thing, the faster that we can get those sorts of things out of our systems, the better. And I think that both of you exemplify this research to practice, practice to research kind of idea we have at the SEI. You've both been in practice, and now you're applying what you've learned to research. And I know you'll be back out again in the practice field, because there's always more to learn here. But today, let's talk about Kaiju. This is a series of tools and capabilities that are built on Ghidra, the NSA's tool. And I want to make sure that people understand, why do we need another tool? Why isn't Ghidra enough? What is it that makes it important that we have Kaiju? What does it accomplish that is unique? Jeff, you want to start us off with that one?
Sure. So Ghidra is an impressive tool set. It does what it is designed to do really well. It's got a compelling infrastructure where it has a fully functional decompiler, and just as importantly, it provides a really interesting programming interface, a programming API, so you can extend it. So we've been working in program analysis, automated malware analysis tooling for a number of years on various different platforms. And the reason we wanted to incorporate Ghidra into that tool chain is because of the decompiler. It allows us to get access to higher level information, to make insights at a low binary level that you can easily apply to the source code level, which opens the doors for all types of different analysis.
So we're basically taking that core capability and then expanding it. It's sort of like a monster that has lots of different arms, where we're creating the new arms that are going to do all the interesting things, and that allows you to deal with new threats. Because I think that's one of the things that we're always about in CERT is we have to have flexible tools that allow us to bring the new threat in and analyze that as well. Is that one of the things that Kaiju helps us with?
Absolutely. I mean, you could think of Ghidra in some respects as a platform for building new tools. And so Kaiju really extends that paradigm where we have a good solid, Kaiju, I guess, means many monsters or in something like that. Garret can correct me on that if I'm wrong, but there are lots of different kinds of Kaiju. And so if you look at what we've actually done, Kaiju itself is a platform for which we build additional tools that will tackle specific problems that we encounter in malware analysis.
Okay. All right. So, Garret, Kaiju's built on Ghidra. So you're not starting from scratch, but tell us, what is it like to build on someone else's tool set, somebody else's platform like that? And what kinds of collaboration did you get to engage in as part of doing that?
Well, one really great thing about Ghidra is that it's open source. And so the fact that it's online and available to researchers allows us to actually talk with both the developers of it through GitHub and conversations and all, as well as researchers that are using it in their practice. And we can all kind of bounce ideas off of each other and report bugs or suggest fixes or whatever it is. So open source really allows us to be able to foster that sort of collaboration. And that's one of the important things that came up with Ghidra, because before this point, so much of this analysis, as I had mentioned before, is done sort of manually and at great expense in terms of time and energy and things. And there wasn't really a big framework like this that had this complete level of debugger and things like that, decompiler, as Jeff mentioned. So it's a very complete tool set, and one other reason I like it is aside from the debugger and the decompiler and all the kind of more technical aspects of it, it also comes with a user interface, which is something that's very lacking for a lot of tools in this sort of space. That a lot of times they're very academic and technical and really hard to get working. And so if we can develop tools that both are very powerful and help analysts, that are also very easy to understand, and you click the green button or something and it gives you your useful information, that's really a win-win for everyone. It allows us to perform our analysis faster, to find problems faster, to get fixes faster, all the stuff I was talking about. So building on top of it is just kind of understanding that framework, going through the documentation, asking questions of the developers and other researchers, learning from what they've learned, and building out our own framework. Kind of understanding the chunks that are missing so far and kind of adding to it to help build our tools, and then making that available for people to build on top of as well, so that we're part of that community collaboration.
So one of the things that has characterized CERT from the very beginning is this collaborative aspect, and this what I see is I call it codification. Kaiju, Ghidra represent codifying a bunch of knowledge that has been very, very hard earned in terms of getting it. As you said, Garrett, a lot of these are very labor intensive, knowledge intensive, experience intensive kinds of techniques. And being able to put them into a platform that allows people that are less experienced, less skilled, less knowledgeable to actually have good results and not make mistakes that especially that beginners are likely to make. I see that as really bringing the state of the practice forward. It's sort of like, when telephony went from having to have specialized operators to actually being allowed to have end users, dial their own phones. We don't remember a time when you had to have an intermediary there. But in many ways, the malware analysis has been a very specialized community. And I'm thrilled to see some of this stuff becoming more available to a larger community because we all have needs in this area. And not everybody has a Garrett or a Jeffrey on their staff, to actually be able to tackle the really hard problems. So I think we're, from a transition viewpoint, we're really making a big step forward with Kaiju. So this is not just on Ghidra, right? This is also part of a larger body of work inside of CERT called Pharos. And Jeff has talked with us about that previously. But Jeff, would you just give us a little bit of an overview on that family of tools so people that are familiar with Pharos but may not be familiar with Kaiju yet kind of can figure out where it fits?
Absolutely. So Pharos, I think you've hit a lot of the high points already. So reverse engineering, malware analysis has historically been a very manual process where you need to find people with a very specialized set of skills, get them to be, get them in your employ, and then, turn them loose. It's just not a whole lot of those resources out there, and it doesn't operate in general, at internet speed. So we set out years ago to try to find new and better ways to automate as much of malware analysis and reverse engineering as we could, and that led us into a couple different interesting directions. One of them was, there's people have been trying to gain insights about how software works without running it for a long time. So in reverse engineering, we have humans do that. But in static analysis, program analysis, people build tools that work on good formalisms to actually, gain insights about a piece of software. So what Pharos was an early attempt to try to merge those worlds, where the static analysis tools, program analysis tools historically worked on source code to find defects, very specialized. Pharos was an attempt to apply some of the static analysis techniques we observed in other domains to reverse engineering at the binary level. A big change in the world since we started that was the maturation of decompilers. They just got better. Hexray's decompiler, Ghidra's decompiler, these are commercially viable tools now. And so we've been continuing to refine our program analysis tools, but with better information. So we get better insights. And so Kaiju is the latest incarnation of that. Right? Some of the tools in Kaiju are designed to be program analysis tools that operate on the data that Ghidra produces, as opposed to data we have to produce ourselves.
Okay. And so as Kaiju evolves and adds more arms into its monstrous toolbox, I'm gonna overuse that metaphor, but I love it. What are some of the areas that you're thinking about now that you're going, Kaiju's great, but what we really need now is X? What are Garrett? What are some of the things that you're thinking about? And Jeff, I'd like both of you to sort of answer that one. Sort of, what are you thinking about next?
Yeah. Some of the problems that I've been very interested in are reachability style problems. So how do I get to a certain point in a program? So with malware, it's not uncommon to have any number of checks to prevent analysis, detect you're running in an analysis environment, detect the presence of a debugger, only run under certain circumstances. And these are all, constraints on what the software will do. So I think we are doing this, but I'd like to continue exploring new and better ways to use Ghidra and Kaiju to automatically determine a viable path through a piece of malware. If I want to get to the part of the malware that does like the badness, whatever that is, what kind of inputs do I have to provide it? And I want to give that information to an analyst so they can kind of separate the interesting bits from the cruft that just goes into all software.
Garret, what about you? What's on your mind in terms of things that you would like to explore further with Kaiju and Ghidra kind of as a platform foundation?
Yeah, so one aspect of the tools that started in Pharos that would aid in identifying and understanding malware is the use of what's known as fuzzy hashing, or the way that we used it is function hashing. And it's a method of trying to identify unique aspects of software, or bits of code that are shared between programs, or maybe unique aspects of those programs, so that we could try to identify which parts of, or for one thing, to identify if a program is malicious to begin with, and then also to be able to compare them to say what aspects of each of these pieces of maybe some malware or ransomware or whatever it is, what do they share, so that we can try to better understand what are their capabilities, what are the things that that they do that we should look out for, so that we can better protect computers and understand what they're doing, so we could remediate it. And we ran into some limitations in doing that with the original Pharos implementation of that tool, because of just all the changes in the way software works. That now, there's many different programming languages that are used, and there's many different hardware architectures that are used. Windows on Intel 32-bit processors was like the dominant thing, but now everyone has ARM processors on their phones in their pocket and things like that now, right? So we're seeing it expand all these different architectures, and that was one positive thing that we got out of moving to the Ghidra platform, that it already had a lot of support for all of these different architectures involved in it. So by sort of taking those methods and moving them over to the Kaiju platform using Ghidra, we're able to kind of expand the reach of those tools. And we're looking into how to better understand and evolve those tools to what we're seeing in modern software on different architectures and things like that. So I'm very interested in better understanding what some of our techniques that used to work for Intel processors, what that looks like on other architectures and other programming languages. We're seeing things go beyond C and C++, right? Things being written in all kinds of different programming languages, and at the bit level, the byte level, they look very different. They're compiled into very different code. So, but we can use the Kaiju and Ghidra platforms in order to, as Jeff said, kind of decompile it and better understand the code. And that gives us better hashing tools that can produce what's known as Yara files that allow us to give that directly to analysts and, IT professionals and all, to better defend their networks.
Gotcha. So you're going to be busy for a while, because I don't think that expansion of hardware architectures is going to slow down. And I don't think the expansion of languages is going to slow down. So you're going to have your work cut out for you, which is good, because we like to be busy and we like to have cool problems to solve. The other side of our work, besides what's the new stuff that we want to deal with, is transition. And for people that are ready to play in the Kaiju sandbox, they're ready to start engaging the monsters. Where do they go, and what resources are available to them? Obviously, Ghidra is open source. We've got Kaiju, Pharos. Where do they find these things, and where do they find help in learning how to use them, especially if they're not a malware expert themselves?
Yeah, so Ghidra itself is available. It's on GitHub, but there's also a website, ghidra-sre.org, that'll point you to the GitHub website where you can download Ghidra itself. And then Kaiju is available through the CMU SEI GitHub page. You can download the source code and look at that directly, or under the releases page, you can actually just download a precompiled extension for Ghidra, and you just point Ghidra at that and it installs it, and then you'll get some pop-up windows that say, hey, you have Kaiju installed now. Do you want to start using tools? And then you can go from there and kind of play with, some of the hashing technology and the pathfinding technology that Jeff was mentioning, and see how that works for you. There's some built-in help manuals in Ghidra that we've started writing to kind of help guide new people. But of course, having everything open source and out on GitHub means that it can be a lot more interactive and collaborative. So folks can always, leave comments or bug reports or something, and get discussion going if they have any questions.
And they do that. And they do. We've built a nice little community around these tools.
Excellent. So transition, you also, I'm assuming you will present about this to virtual conferences, not so much live anymore, but we have blog posts and other resources at the SEI in terms of comms that I also want to highlight. If you were my age and you listen to Garrett's answer, it's kind of scary because he didn't say anything about tutorials or classes or anything. And I'm from that generation that goes, but I can't possibly start using it without some kind of instruction. But we have some of those kinds of things too. Just in other generations, it's much more important to get directly at the code, and I get that too. So I do want to thank both of you for talking with us today about this work and for being so creative in naming it and giving me some Friday afternoon entertainment. So I am very happy that we are continuing in this path to making very, very complex needed tools and skills and knowledge available to people that are not the world experts in this, because I think that's the way that we actually manage security in today's world. For our audience, I just do want to remind you, as always, we will include links in the transcripts to the resources that we mentioned, the websites, etc. And we'll also have the blog posts and things that are available to you. So I want to thank our audience for joining us today and talking about monsters killing monsters. And I want to thank Jeff and Garret for sharing their insights into how these are evolving and are available for everybody to use now. So that's exciting. All right. So thank you very much, and go forth and kill all those monsters.
Thank you.
Yep. Thank you.
Thanks for joining us. This episode is available where you download podcasts, including SoundCloud, Stitcher, TuneIn Radio, Google Podcasts, and Apple Podcasts. It is also available on the SEI website at sei.cmu.edu/podcasts and the SEI's YouTube channel. This copyrighted work is made available through the Software Engineering Institute, a federally funded research and development center sponsored by the U.S. Department of Defense. For more information about the SEI and this work, please visit www.sei.cmu.edu. As always, if you have any questions, please don't hesitate to email us at info@sei.cmu.edu. Thank you.